maths class. We had a look at...
Oh my god, I can't believe like next week I don't have maths. I can't even imagine my week.
Shut up!
It's like a normal week for you.
Last time we had a look at sequence and series. And we looked at general formula for sequence and then for series as well. But there are two special types of situations which we're going to look at today. The first type is called arithmetic, or just AP for short. So this is a sequence that looks like this. The terms you get by adding the same number each time. So for example, this sequence here is 6, 10, 14, and so on. What am I adding each time? 4. So I'm doing plus 4 plus 4. So this... Hey, come on, you need to start focusing now. This is an example of an arithmetic progression. Progression. It's the name of the lesson, page 50. You need this vocabulary for the exam. You need to know these words. So this is an example of an arithmetic progression. So we need to be more precise.
What do you call it?
Arithmetic. Yeah. It's the name of the lesson. Now, what's special about this sequence is that the next term is the previous term plus d. Okay? So the next term is the previous term plus d.
Plus 1 into d.
Yeah. So if I start with a as my first term, then the next term would be something like a plus d, and then the next term would be a plus 2d, and a plus 3d, etc. That you're adding d each time. So the a is called the first term, and then, does anyone know the name for the d? Yeah, common difference, yeah. But you're right. So these are the vocabulary for arithmetic progression. And like I said, AP for short. A is the first term and D is the common difference.
Can you write the general formula?
Yeah, and that's what we're going to have a look at first. So, if you look at it like this, U1 equals A, U2 equals A plus D, U3 equals A plus 2D. So what you're noticing is that this here is always one smaller than the term you're on. So for example, we can jump all the way to the 11th term, would be A plus 10D. So this gives us our first formula. Yeah, UN is A plus N minus 1D. So this is the formula to find any term in the arithmetic progression. So let's have a look at some examples then. Yeah? No, talking. Now, first example. For this sequence, this is like 1a, 0, 4, 8, etc. I just want you to tell me what the first term is and the common difference. So you can see clearly the first term is 0. It starts at 0. And what is the difference? 4. So just to get started, that's all you need to do for question 1. Now, the next example. You have minus 9, minus 14, minus 19, etc. And this time I want the nth term. So this is the first, this is the second, this is the third. I want the nth term. So using my formula, un equals a plus n minus 1d. That is minus 9 plus n minus 1. And if you're not sure what the d is, you can just do this number minus that number. So minus 14 minus 9 is going to be minus 5, isn't it? So we have minus 5 here. You should multiply this. In the exam they would expect you to. Minus 9 minus 5n plus 5. So un would be minus 4 minus 5n. Now you can check that this is right. If you put n equals 1, what do you get? You get minus 4 minus 5, which is minus 9. If you put n equals 2, you get minus 4 minus 10 minus 14. And you can check with the last one again. If you put n equals 3, you get minus 4 minus 15. That's minus 19. So this is the formula for the nth term, any term you want. Okay. So I'm going to do more examples now using this formula. So that was 1a and 2a. So now on to 3a. Can I scroll down? Yeah? Can I scroll down? Yeah. Okay, so next example. So we have this arithmetic sequence 9, 18, 27, and I don't tell you the next terms, but I tell you what the term is at the end. So just to be clear here. So you know the first term is 9, the second term is 18, the next term is 27, etc., etc., etc. The last term is 126. And I would like to know in this question how many terms I have.
That's the end.
The end, yeah, exactly. So we know that the answer is going to be at least 4, but it's going to be more than 4 because we have already 4 terms there. So whatever answer we get, we should get something more than 4. We know that, okay? And it should be a natural number, like 4, 5, 6, 7. Okay? So how do we find out how many we have? So the way we do this is we take the last term, 126, and we make it equal to un. And this is what gives us the n for how many terms we have. So we use our formula again. A plus n minus 1 times d equals 126. What's a here? 9. And what's d? 9. What type of equation is this? What's it called? It's just a linear equation. 9 plus 9n minus 9 equals 126. That cancels that, and that can be taken down there. Was it 13? 14, sorry. So n is 14. We should check if that answer is right. So let's check it. U14 equals a plus n minus 1 times d. So that's 9 plus 13 times 9, which is 126. So there are 14 terms in this sequence, starting at 9 and finishing at 126. So there are 14 terms. You could even do this in Excel. You know, you could have Excel go 9, 18, 27, and you can see when you get to row number 14, you'd have 126. Okay. Now I'm mentioning Excel, and I showed you me using Excel this week for this topic. And that's important because as part of your maths assignment after the break, you'll have to use Excel, and it's related to sequence and series. Okay, so it is important that you do make these sequences in Excel for practice sometimes. Okay, right. Next now, 4a. Okay, can I scroll down? Yeah. So 4a. So in number 4a, I tell you that the 7th term is minus 13, and the 17th term is minus 23. I only tell you I only give you two terms in the sequence. I tell you what is the 7th, and then I tell you what is the 17th, and that's it. But that's enough information. You only need to know two terms, and you can work out what the A was and what the D was. So again, it's using the same formula. We say U7, that's A plus n minus 1D. That's to equal minus 13. But we know what the n is at least. It's 7. So we get A plus 6D equals minus 13. We also know that the 17th term, that should be minus 23. So we know that A plus 16D should equal minus 23. So the situation is similar to what you've done already. In fact, it's exactly what you've done already. You have two equations here with two unknowns, and you can use any method you like. What do you think would be the best method to use for these two? Yeah, which method? Elimination, because you already have the A prepared. So if I do the second one minus the first one, A minus A is gone. 16D minus 6D is 10D. And then minus 23 minus minus 13 is minus 10. So D equals minus 1. How can I find the A? Sub it back in, let's say the first one. A equals minus 13 minus 6D. That equals minus 13 plus 7, which is, isn't it minus 13 plus 7 minus 7?
Yeah.
No.
Minus 7.
Is it? No, it's not. Minus 6. A equals minus 6. So we have our two answers. D is minus 1 and A is minus 6. So you just need two terms from an arithmetic progression, an arithmetic sequence, and that's enough to find the A and the D. No? Did I make a mistake?
Minus 7. Told you.
Wow, I wrote 7 because 6 times 1 is 7, right? Yeah. Fail. Yeah, okay, sorry. So this here should have been plus 6, making this minus 7. Thank you. Okay. Right, now I have another formula to do. So I've just done 1, 2, 3, 4 examples of when you would need this UN formula. So this is for sequence in arithmetic progression. But now we're going to look at a series when we add all the terms together. So for example, you have something like this. 6 plus 10 plus 14, etc. So it really is the same situation, except we want to add all of the numbers together. So I'll just give you a little bit of notation. When I write S, it means sum. S1 is just the first one. S2 is the first term plus the second term. S3 is the first plus the second plus the third, etc. So that's what the S means here. So we would like to try and find a formula now for Sn. So for Sn, can I scroll down? Yeah. So for Sn. Yes? Yeah, okay. Now, yeah, we're going to work it out. So Sn n. It's the first term plus, I'll use brackets here, the second term, which is a plus d, plus the next term, which is a plus 2d, and that continues all the way until the last term. How many terms are in this series? N. So what is the last term? A plus, no, n minus 1 d. It's the nth term at the end. Now, the way we get the formula is we write down this series again, except we start from the back. A plus n minus 1 d plus, I'm just writing it out but in reverse order. It does not matter that I write it out backwards because we're adding. It'll be the same number, won't it? X plus y is the same as y plus x. Now, what I do next is I add these equations together. So this will be 2 Sn. Now, as an example, I'll just do this piece at the side. Okay? So at the side here as an example, we have a plus n minus 1d. So that's the same as, a plus nd minus d. Oh wait, yes, and that's it. So what do I get here? 2a plus n minus 1d. Now, if I was to do the next one, so let me just remove that. Let me have a look at the next one. It would be a plus d, and then underneath it'd be a plus n minus 2. N minus 2d. Now let's add them together. A plus d plus a plus nd minus 2d. That is 2a plus nd
2a.
minus d. Oh yeah, 2a. No, that's right, isn't it?
Minus d.
Yeah. Which is 2a plus n minus 1d. This is the point I'm making. When you add these together, you get the same answer each time. You'll always get 2a plus n minus 1d. And then when you go to the next one, it'll be the same. All the way back to the start, or to the end here. So you'll always get plus 2a plus n minus 1d. It's going to be the same each time. Now, we can do a lot now, because if you add the same number to itself many times, like 5 plus 5 plus 5, that's the same as 3 multiply 5. Right? 6 plus 6 plus 6, 3 multiply 6. So, how many terms do I have here? N of them. Yes. So I can change all of this into just n multiply 2n plus n minus 1d. And here I still have 2Sn. Now what was I looking for? I was looking for Sn, the sum. And I nearly have it. I just need to finish by dividing by 2. And this gives my formula. Sn equals n over 2, 2a plus n minus 1d. That's the formula for Sn. Okay?
Do you need to go above that?
Yes. No. The proof is good for your health, though. It's like exercise. Okay. So let's see an example of using this formula. So this formula, and then I'll go back, don't worry. Where's it gone? This one here, both formulas you need for arithmetic progression, and it's the only two you need. So there's only two formulas.
No,
They'll be in the formula book. Yeah.
we're not doing geometric.
And then geometric, yeah. Yeah. Can I show you an example of this now? Yeah? You got this formula? Yeah. So, let's take a simple one to demonstrate the formula. So we have something like 5, well, let's do the one we had here. 6 plus 10 plus 14. What's the A here? 6. The D? 4. And the N? 3. Now, you can easily type that in on the calculator. What should the answer be? Well, it should be 30. Okay? But let's check if we get 30 if we use the formula. So it's S what? What number do I write here? S3. Because there are 3 things I want to add. Is, what's the formula? N over 2, 3 over 2, 2A plus N minus 1, 2, times 4. And that will be 30. Because it'll be 3 over 2, and then that's 20. I can see 2 goes into that to make it 10, and then 3 times 10, that is 30. Okay, so it is 30. Now I hope you can see the advantage. The advantage is it's much quicker to do this if you had a very large n. So if you had 300 terms, it takes the same amount of work as if you had 3 terms. So this is the advantage. So I would like you to do that for me. If n was 300, tell me what the answer would be. So just type this in, but n is 300. What do you get? What is it? 181200. Yeah? Now, can someone also get for me what is the 300th term using the UN formula? So that is A plus 3000, sorry, not 3000, 300. A plus 299D. Yeah, I want term number 300. What's that? What is it? 1202. So this is the result that you have. You can say 6 plus 10 plus 14, etc., 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 until you get to 1202. If you add them all together, you'll get this number, 181200. So this is the advantage with this formula. It takes the same amount of time, even if you have hundreds and hundreds of terms to add together. So let's have a look at some examples from the book now. Can I scroll down? Yeah. So I'm going to do 5A. I want to calculate S40, and I'm adding together 8 plus 11 plus 14 all the way to 125. So I just use my formula. What's the n? What's n? 40. 40 over 2. 2a. What's the a?
8.
Yeah. N minus 1. And d. And what do we get? 2660. That was number 5A.
What's the point of 125?
Here, not necessary. You didn't need to use it, but you would need to use it for a later question. But I'm just telling you in the question that the 40th term is 125. And in fact, there's another formula that you can use. I think it's what they maybe use in China, I'm not sure, but it's something like the first plus the last term. There's a form like this, first plus the last divided by 2. I can't remember what it is, but some students like to use that formula, so they need the last term for it. Yeah? Okay, I'm going to do now 6A. So I want the sum of the first n terms. So in this situation, I do not tell you how many terms there are. I want you to leave it as n. So we get Sn equals n over 2, 2a plus n minus 1 times d, which is 8, isn't it? Yeah. We need to simplify this. Sn is n over 2, 10 plus 8n minus 8, which is n over 2, 2 plus 8n. Now, what can I cancel on the top and the bottom? 2. So I get n, 1 plus 4n. So I get 4n squared plus n. Okay. So let's see what happens here. If I put n equals 1, what number do I get? No, I'll try again.
5.
5. Now if I put n equals 2, what do I get in this here? What do I get?
20.
Hang on.
2.
2 squared is 4, 16 plus 2, 18. If I add the first two numbers together, 5 and 13, what do I get? 18. Let's just check the next one. If I put n as 3, 3 squared? 9 times 4?
36.
36 plus 3?
39.
Yeah, and then 5 plus 13 plus 21 should be the same. Yeah? So this lets you add up as many terms as you like from it. And this is common in the exam. Actually, pretty much anything here is what you get in the exam. But the good news is there's not many ways they can ask you this question. It will pretty much look exactly like how it is in the book. Usually section B. Yeah. Okay, let's have a look now. That was 6, now 7. 7a. Can I scroll down? 7a. So now, this one here is similar to what I did earlier, but there's one complication.
We didn't do
Yeah. I don't know what the n is. I know what the a is. What's the a? What's a? Minus 8. And I know the d. Minus 3. Do I know the n? No, I don't. But I know how to find the n. I make un equals minus 113. So I get a plus n minus 1 d equals minus 113. This can give me the n. Minus 8 minus 3n plus 3 equals minus 113. So I will get 113 minus 8 plus 3 equals 3n. So that would be 116 minus 8, 108, which can be divided by 3, 30 something, 86, 36?
Yes, 36.
N is 36. Now I can go back to my question and actually answer it now that I know the n. So the answer is Sn equals n over 2, 2a plus n minus 1 times d, which is minus 3. So what do I get for that, please? Can you type it in? Minus 217. Minus 2178. Yeah, with a minus. Yeah. Yes.
Where did you get the UN equals next to that?
Where?
Oh, I know it's from the question, but
Why?
why?
Yeah, why, not where. Yeah. I don't know how many terms there are. But we saw earlier today, when you want to work out how many terms there are in a sequence, you make un equal to the last term. So if I don't know how many terms there are in the sequence, I just make un equal to the last term. Please don't make me separate people, okay? The 7 people there are drawing my attention a lot. Yes?
Just don't pay attention.
If only. Okay, so I make un equal the last term. This is what I do when I don't know how many terms there are. I think this was like number 3. Okay. Right. Now on to number 8. Can I scroll down? Yeah. Okay, so in number 8, I tell you, the sum of the first 19 and 22 terms are that and that respectively. So I say the sum of the first 19 terms is 228, and the sum of the first 22 terms is 297. Yeah. So the sum of the first 19 terms is 228, and the sum of the first 22 terms is 297. And again, this is enough information to get the A and the D. Okay, so I start off with the first one, n over 2, 2A, which I don't know, plus n minus 1, D. That should equal 228. And likewise, for the second one, n over 2, 2a plus n minus 1d. That should equal 297. Now we should clean this up a little bit. What I'll do to clean it up is I'll multiply both sides by 2 over 19, and here, well, that's 1 over 11, 2 over 22. So I get now 2a plus 18d, what does it equal? 228 times 2 over 19, please. Yeah. 24. And then for the next one, 2a plus 21d equals 27. Now, what method should I use to solve this pair of equations? Elimination. I subtract. Yeah, second minus first. 3d. Yeah. So d equals 1. I can take that back in there to get the a. 2a plus 18 equals 24. 2a equals 6. So then a equals 3. So I have my A and my D now. Okay, one more example to do from this. I can scroll down now? Yep, okay. So the last one, last type of problem, so this will be like 9a. Do you need a, come on. 9, that was just 8a. So now it's 9a. I can scroll down? Okay. So, 9a, I tell you, 2 plus 9x 3 minus 4x minus 4 plus 6x. I tell you that these three numbers are in arithmetic progression. You don't know what x is, but whatever x is, it makes three numbers here that put these in arithmetic progression. You don't know what x is. So for example, if I was to make x 0, what numbers do I get? 2, 3, minus 4. Is that an arithmetic progression? No, it's not. Because how do I go from 2 to minus 3? I do a minus 5. But how do I go from, 2 to 3, yeah.
Plus 1.
2 to 3, I do a plus 1. But 3 to minus 4?
Minus 7.
Yeah, minus 7. So it's not an arithmetic progression. There is some number x that makes these become an arithmetic progression. And we need to find that number x. So what we do know about arithmetic progression is that we know if I add d to this number, it will make this number. True? And if I add d to this number, it will make that number. Therefore, if I take this number and minus this number, what should I get? D. And if I take this number and minus its neighbour, what should I get? I should also get D. Because the difference each time is D. So you know that D will equal 3 minus 4x minus 2 plus 9x. Now, if you don't want to say that, another way to say it is you could have said 2 plus 9x plus d. What should that equal? 3 minus 4x. But it doesn't matter which way you say it. No, choose one. Okay? It doesn't matter. I will stick with d equals 3 minus 4x minus 2 plus 9x. Likewise, d equals minus 4 plus 6x minus 3 minus 4x. Two equations, two unknowns. What method would be best here if I want the x? Equate. Substitute. Yeah. So I have 3 minus 4x minus 2 minus 9x equals minus 4 plus 6x minus 3 plus 4x. So I get minus 13x plus 1 equals 10x minus 7. So here I get 23x, and then here I get 8. So that's, that's a fraction, is it? I wonder if there's a, oh no, it is a fraction, okay. X equals 8 over 23. Let's put x back in here and see if it is arithmetic. So can someone type in 2 plus 9 times 8 over 23? What do we get? It's a fraction. Can you put it as a fraction? Yeah. 118 over 23. And what's next now? The next one? What is it? 37 over 23. So the last one is probably over 23 as well. What is it? $23?
Yeah.
Okay. It's not clear, but it is an arithmetic progression because each time it's getting smaller by the same amount. 63, 73, 83, 81. Each time it gets smaller by 81 over 23. It is 81 over 23?
What? No calculator.
So here, if I do minus 81 over 23, I get this. So the next one would be the same, minus 81 over 23. So it is arithmetic. I can't imagine any question that they could ask you that I've not done. Okay? So I do like the arithmetic and geometric questions in the exam because I feel like they're pretty standard. There's not much you can do other than what I just did there. So your questions in the exam, I've never seen one that's not like what's on page 50.
They don't give them as practical questions where.
Oh no, that'll be later. Yes. Yeah. Okay. So questions which I want you to start now. Two from each, the last two.